service-rated panel can indeed have additional spaces, even if you do not install more than 6 mains. Article 230.71 of the National Electrical Code prohibits the installation of more than 6 main circuit breakers or fuses in a service-rated panel board. However, this rule does not specifically address the issue of empty spaces. Therefore, it is acceptable to have additional empty spaces in a service-rated panel, provided that the number of installed mains does not exceed 6. Regarding lighting panel boards, if a panel meets the criteria outlined in Article 408 of the National Electrical Code as a lighting panel board, it does not necessarily require a main breaker or overcurrent protection. Article 408.42 specifically states that a lighting assembly or panel board that exclusively controls lighting fixtures is not required to have a main overcurrent device. Consequently, empty spaces in a lighting panel board do not automatically necessitate overcurrent protection. To elaborate further on service panels, it's important to understand their function. The service panel, also known as the main panel or load center, is the central distribution point for electricity in a building. It receives power from the utility company and distributes it to various branch circuits throughout the structure. A service-rated panel is specifically designed and labeled for use as the main disconnect for the entire electrical service. The 6-disconnect rule, as mentioned in Article 230.71, limits the number of main disconnecting means to a maximum of 6 switches or circuit breakers. This rule is intended to ensure that in an emergency, all power to a building can be quickly and easily shut off by operating no more than 6 devices. Therefore, even if a service-rated panel has more than 6 breaker spaces, only 6 of those spaces can be used for main disconnects. The remaining spaces can be used for branch circuits or left empty. Now let's delve deeper into lighting panel boards. A lighting panel board is a panel board specifically designed to supply power to lighting circuits. These panel boards are often used in commercial and industrial buildings where there are numerous lighting fixtures. As stated earlier, Article 408.42 of the National Electrical Code provides an exception for lighting panel boards, allowing them to be installed without a main overcurrent device under certain conditions. This exception applies when the panel board exclusively controls lighting fixtures. The reasoning behind this exception is that lighting circuits are typically protected by individual branch circuit overcurrent devices, such as circuit breakers or fuses. These devices provide adequate protection for the lighting circuits, making a main overcurrent device unnecessary. However, it is crucial to note that this exception only applies if the panel board exclusively supplies lighting circuits. If the panel board also supplies power to other types of loads, such as receptacles or appliances, then a main overcurrent device is required. To further clarify the requirements for overcurrent protection in panel boards, it's essential to understand the purpose of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. Overcurrent can result from various factors, including short circuits, ground faults, and overloads. When an overcurrent occurs, the overcurrent protection device will trip or blow, interrupting the flow of electricity and preventing damage to the circuit and equipment. The National Electrical Code provides detailed requirements for overcurrent protection in Article 240. This article specifies the types of overcurrent protection devices that are permitted, the ratings of these devices, and the installation requirements. In general, each ungrounded conductor in a circuit must be protected by an overcurrent device at the point where it receives its supply. The rating of the overcurrent device must be based on the ampacity of the conductor it protects. The ampacity of a conductor is the maximum amount of current it can safely carry without overheating. The National Electrical Code provides tables that list the ampacities of various types of conductors based on their size, insulation type, and installation conditions. In addition to protecting conductors, overcurrent protection devices also protect electrical equipment from damage caused by overcurrent. Many types of electrical equipment, such as motors and transformers, are equipped with their own internal overcurrent protection devices. These devices are designed to protect the equipment from damage caused by overloads or short circuits. Now let's discuss some practical considerations related to empty spaces in panel boards. While it is permissible to have empty spaces in both service-rated panels and lighting panel boards, it's important to ensure that these spaces are properly managed. Firstly, all unused breaker spaces should be covered with blank filler plates. These plates prevent accidental contact with energized parts inside the panel board. Secondly, it's important to keep the panel board clean and free of debris. Dust, dirt, and other contaminants can accumulate inside the panel board and potentially cause electrical problems. Thirdly, it's important to properly label all circuits in the panel board. This will make it easier to identify and troubleshoot circuits in the future. The National Electrical Code requires that all circuits be clearly and legibly labeled. The labeling should indicate the purpose of each circuit, such as lighting, receptacles, or appliance. In addition to the requirements outlined in the National Electrical Code, there may be local codes or regulations that apply to electrical installations. It's important to consult with the local electrical inspector to ensure that all installations comply with applicable codes and regulations. Furthermore, it is highly recommended to hire a qualified electrician for any electrical work. Electrical work can be dangerous, and it's important to have the necessary knowledge and experience to perform the work safely and correctly. A qualified electrician will be familiar with the National Electrical Code and local codes, and they will have the tools and equipment necessary to perform the work properly. Remember, electrical safety is paramount. Always take precautions to protect yourself from electrical shock and other hazards. Before working on any electrical equipment, always turn off the power at the main disconnect. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and rubber gloves. If you are not comfortable working on electrical equipment, then hire a qualified electrician. To summarize, a service-rated panel can have empty spaces as long as the number of main disconnects does not exceed 6, as per Article 230.71 of the National Electrical Code. A lighting panel board that exclusively supplies lighting circuits is not required to have a main overcurrent device, according to Article 408.42. Always ensure that all unused breaker spaces are covered with blank filler plates. Keep the panel board clean and properly label all circuits. Consult with the local electrical inspector and hire a qualified electrician for any electrical work to ensure compliance with codes and regulations and to prioritize electrical safety. Moreover, understanding the specific voltage requirements for different types of equipment is crucial for safe and efficient electrical installations. For instance, residential lighting and small appliances often operate on 120 volts, while larger appliances like electric stoves and dryers may require 240 volts. Commercial and industrial settings frequently utilize 208 volts, 277 volts, or 480 volts for various equipment and machinery. The National Electrical Code provides guidelines on selecting the appropriate voltage levels and wiring configurations for different applications. It's also important to consider the ambient temperature when selecting conductors and overcurrent protection devices. High ambient temperatures can reduce the ampacity of conductors, potentially leading to overheating and failure. The National Electrical Code provides correction factors for adjusting conductor ampacities based on ambient temperature. Similarly, the operating temperature of overcurrent protection devices can affect their performance. It's essential to select devices that are rated for the expected operating temperature. Furthermore, the type of wiring method used can impact the ampacity of conductors. Different wiring methods, such as conduit, cable, and open wiring, have different heat dissipation characteristics. The National Electrical Code provides tables that list the ampacities of conductors for various wiring methods. When selecting conductors, it's important to consider the dating factors that may apply due to factors such as conduit fill, grouping of conductors, and ambient temperature. Dating factors reduce the allowable ampacity of conductors to prevent overheating. In addition to overcurrent protection, ground fault protection is another important aspect of electrical safety. Ground fault protection devices are designed to detect and interrupt ground faults, which occur when current flows through an unintended path to ground. Ground faults can be dangerous because they can cause electrical shock and fire. The National Electrical Code requires ground fault protection in certain applications, such as in bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FCIs, are another type of protection device that is designed to prevent electrical fires. FCIs detect arc faults, which are dangerous electrical discharges that can occur due to damaged or worn wiring. When an arc fault is detected, the FCI will trip, interrupting the flow of electricity and preventing a fire. The National Electrical Code requires FCIs in many residential circuits, particularly in bedrooms. Surge protection is another important consideration for protecting electrical equipment. Surges are sudden increases in voltage that can damage sensitive electronic equipment. Surge protection devices, or SPDs, are designed to divert surge current away from the equipment, protecting it from damage. The National Electrical Code requires surge protection in certain applications, such as in hospitals and critical infrastructure facilities. When installing electrical equipment, it's important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide guidance on proper installation techniques, wiring configurations, and safety precautions. It's also important to use the correct tools and equipment for the job. Using the wrong tools can damage the equipment or create a safety hazard. Regular maintenance is essential for ensuring the safe and reliable operation of electrical systems. Maintenance tasks may include inspecting wiring, tightening connections, and testing overcurrent protection devices. It's important to keep accurate records of all maintenance activities. If you encounter any problems with your electrical system, it's important to have them repaired promptly by a qualified electrician. Ignoring electrical problems can lead to more serious issues, such as electrical fires. Finally, always be aware of the potential hazards of electricity and take precautions to protect yourself and others. Electricity is a powerful force, and it must be treated with respect. By following safe work practices and adhering to the National Electrical Code, you can help to prevent electrical accidents. Always ensure that the power is turned off before working on any electrical equipment. Double-check the voltage of the equipment you are working with before starting any repairs. Never work on electrical equipment when you are wet or standing in water. Always wear appropriate personal protective equipment such as safety glasses and rubber gloves. If you are not comfortable working on electrical equipment, then hire a qualified electrician. They have the tools, training, and knowledge to properly handle electrical wiring safely. One of the most common electrical misunderstandings that people make is believing that the electrical panel is the most important part of the electrical system. The truth is, every component in the electrical system plays a vital role in the overall operation of the system. Without proper wiring, the electrical panel would not be able to distribute power safely to all of the outlets and appliances. Without proper outlets, the wiring would not be able to deliver the electrical power safely. Without proper grounding, electrical shocks are more prone to occur. And without proper overcurrent protection, electrical fires are more prone to start. So it is safe to say that every part of the electrical system is equally important.